In this question, we're asked to calculate the definite integral from x equals 1 to x equals 2 of x squared ln x dx. So when faced with an integration problem, we always ask ourselves what method would be the most appropriate to try here. And because we have two functions multiplying each other, probably a good bet to try integration by parts, but that's not always the case, so we have to think about it a little bit more. The key feature of integration by parts is it results in another integral which has the derivative of one of the functions in it. So the derivative of ln x is 1 over x, and so that would be kind of nice to have because it would cancel out with part of this x squared. So perhaps that would be a good idea to try. So let's go ahead and try to do it. So we have the integral from 1 to 2 of x squared ln x dx. And so now I have to choose u and dv by dx. The u should always be something easy to differentiate. Both of these are easy to differentiate. And the dv by dx should be something easy to integrate. Dv by dx should be x squared because ln x is hard to anti-differentiate. So we're going to choose this to be our u, and we're going to choose this to be our dv by dx, which allows me to go over here and make up the rest of my pieces of my formula. So u is equal to ln x by choice, which means the u by dx is equal to 1 over x. V I don't know yet, but I do know that dv by dx is equal to x squared, which means v is the antiderivative of that, which means it's 1/3 x cubed. Okay, so now I can go ahead and use my formula. I have u times v, which is 1/3 x cubed times ln x. And of course, this has to be evaluated from 1 to 2 because this is a definite integral. And the other part of the formula says I still need to integrate from 1 to 2 of v, which is 1/3 x cubed, times du by dx, which is 1 over x dx. Okay, so this is still 1/3 x cubed ln x, and I'm just going to save all the evaluation to the end. Minus the 1/3 can come out. This x cancels out with the x cubed a little bit, so this becomes 1 to 2 x squared dx. And now I'm almost there. I just have to finish this much simpler integration now. This antiderivative is 1/3 x cubed, so this becomes 1/3 x cubed evaluated from 1 to 2. And now I'm in a position to actually do these evaluations. So the first part, I'm going to plug 2 into my function. So I get 1/3 times 2 cubed ln 2 minus what I get when I plug in 1, which is 1/3 1 cubed and times the logarithm of 1 minus this 1/3 is out front of this whole thing. Plug in the 2 and I get 1/3 2 cubed minus what I get when I plug in 1, which is 1/3 1 cubed. And now I can simplify all of this. I have 1/3 2 cubed is 8, so this becomes 8/3 8/3 ln 2. This ln 1 is just 0, so this whole term goes away. Minus 1/3, and then what do I have in here? This becomes 8/3. I have 8/3 minus, this just becomes 1/3. So the inside of here becomes 7/3. This becomes 8/3 ln 2 minus 1/3. Of course, there's 7/3 in here. And so at the end of the day, the final answer to this definite integral is 8/3 ln 2 minus 7 over 9.